Today we're doing right triangle trigonometry, day 2, and we're going to look at different identities that will help us with the relationships among the 6 trig functions. So the first set of identities we're going to learn are called reciprocal identities, and just as the name states, there is a relationship between the reciprocals, and the first one will be the sine of theta. We know from the previous section that the reciprocal sign is cosecant, which means that sine is the same thing as 1 over cosecant, or cosecant of theta is the same as 1 over sine of theta. So those are reciprocals. And then cosine of theta is the same thing as 1 over secant theta, or vice versa. Secant of theta is the same as 1 over cosine theta. And then we have tangent of theta is the same thing as 1 over cotangent theta, or vice versa. Cotangent of theta is the same thing as 1 over tangent of theta. And we usually use these when you have an example. Say, for instance, you had something like you were trying to simplify sine theta times cosecant of theta. And it doesn't matter what theta is as long as they're the same angle. You can even have like sine pi over 3 times cosecant pi over 3. Well, we know that, and it doesn't matter which one you change. Say I want to change sine, or actually, say I wanted to change cosecant. So we know that from our above identities that cosecant is 1 over sine of the same angle. And if you multiply it together, since they are identities, when you multiply them, those cancel and you get 1. Anytime you multiply a function by its reciprocal identity, then you would get 1, because that's usually why they call it identity. So you only use these when you're trying to like simplify it to something that can cancel out. Quotient identities are next. Quotient meaning division. And we have tangent of theta is the same thing as sine of theta over cosine theta. And remember, theta is just the angle. It could be in radians or degrees. And just like its reciprocal, cotangent of theta will be the reciprocal of the ratio we just formed, which would be cosine theta over sine theta. And we're going to be using these identities a lot, so it's very good to know the difference. And quotient identities are good when you're trying to find the value of for the 4 remaining trig functions. So if you know 2, you can find the other ones. For example, let's say they gave us that sine theta was 2/5 and cosine theta was the square root of 21 over 5. Well, we can use our identities to find the other 4 trig functions. So from what was just given, tangent of theta is sine over cosine. So sine was 2/5. Cosine was the square root of 21 over 5. And if you remember, dividing fractions is the same thing as multiplying. So you're going to do keep, change, flip. Change meaning you're changing the division to multiplication. And then these would cancel. And here you have a case where you have to rationalize the denominator. And if you remember to rationalize it, you multiply top and bottom by the square root of 21. 2 square root of 21 over 21. And the good thing about this is if we have tangent, we also can find cotangent by doing the reciprocal of tangent. And I would, when you're doing the reciprocal, to make it easier, I would flip the original, not the one that we found the, or we rationalize the denominator. So I would do the reciprocal of that one. So if you do that, let me put this back so you'll see. Then the reciprocal would be square root of 21 over 2. And then, since we have sine, we have its reciprocal, which would be cosecant. And since sine was 2/5, cosecant would be 5/2. And since we have cosine, then we can also find secant of theta, which would be 5 over the square root of 21. Now this one we will have to rationalize. So it would be 5 square root of 21 over 21. So see, reciprocals and the identities help us define. And there you'll see we have all 6. The 2 that they gave us, and 1, 2, 3, 4 we use as the reciprocals. These are the Pythagorean identities, kind of like the Pythagorean theorem. So this is sine, sine squared theta plus cosine squared theta always equals 1. As long as those two angles, and they can be in degrees or radians, as long as it's the same angle, it always equals 1. And then the next one you have 1 plus tangent squared of theta is always equal to secant squared of theta. You can rewrite this if you get 1 by itself. Secant squared theta minus tangent squared theta is equal to 1. So either one of those is correct depending upon what you have in your problem. And then the last one is 1 plus cotangent squared of theta is always equal to cosecant squared of theta. And if you want to rewrite it and get 1 by itself, cosecant squared theta minus cotangent squared theta is always equal to 1. And then an example of this would be, let's say they gave you sine theta was 3 over 5. And they wanted you to find cosine of theta. And see, we really couldn't use those other identities because we only have one trig function. You You could find it by drawing a triangle. That's another way you can do it. But if they ask you to use the Pythagorean identity, then you have to use one of the three above. And so, since we have sine and we need cosine, it's best if you use the first one. So it depends on what they give you. So what you're going to do is plug in the information. So I'm just rewriting the formula so you can see which formula I'm using. And they're giving us that sine theta is 3/5. But notice that this says sine squared. So what you're going to have to do is when you plug in 3/5, you have to square it. And then you're going to do this like a regular algebra problem. I'm going to rewrite this so it's clear. You're going to actually solve for cosine squared theta if it was like x squared. So first you would square this, which would be 9 over 25, because you have to square the top and the bottom. And then what I'm going to do is change this 1 to 25 over 25. That way it makes it easier for me to subtract 9 over 25 from both sides. So if I subtract that, that'll give me 16 over 25. And anytime you see a square, then you're just going to square root both sides. So cosine of theta would be the square root of 16, which is 4, over the square root of 25, which is 5. Since they said theta has to be acute, you can't have plus and minus. Because you remember, acute angle has to be greater than 0 but smaller than 90. So this would be your answer. The last set of identities are the cofunction identities. And when I think of cofunctions, this relationship or these relationships kind of sound like the names because we are complementing when you think of the word co. So that's one thing you want to remember. For example, you have sine theta. And the complement is cosine. And if you look at this here, that'll help you remember sine, cosine. And complements, if you remember from geometry, there are two angles that have to add up to 90 degrees. So if you already have theta or sine of theta, to find cosine, then you have to do 90 degrees minus that original angle that they gave us. And then you do the same thing if you have cosine theta and you needed to find the cofunction. You would use sine and you would take 90 degrees and subtract theta to give you its cofunction. And you can use the same with radians. If they give it to you in radians, then instead of using 90 degrees, you'll use the radian measure, which is pi over 2, minus whatever theta was. And the same thing if they gave you cosine in radians. Then you'll just change the 90 degrees to radians. But on the radians, you'll probably have to use get common denominators. Then you have tangent. Well, tangent is one of the easier ones because, of course, its cofunction is cotangent. And I'm not going to spell out the whole word. I'm just going to use COT. And there's cotangent, cotangent. And so here you would do 90 minus theta Same thing if they give you cotangent. Then you would use tangent, and it'll be 90 minus whatever theta was. And if they give it to you in radians, you're going to do the same thing as before. You'll use pi over 2. And the same thing over here. You'll just change the 90 to pi over 2. And then the last relationship would be secant. And its cofunction is cosecant. So you have to really pay attention to what they're asking you to find, because you don't want to confuse cofunctions with reciprocals. And at least when they ask you for cofunction, you're looking for that relationship. And here I'm doing the same thing. If they give it to you in radians, then of course you would use pi over 2. And over here, same thing. So what I'm going to do is give you an example where they ask for degrees and when they ask for radians. So for example, let's say they wanted you to find the cofunction. And they were given, or you were given sine 72 degrees. Well, the cofunction for sine is cosine. So you would do sine of 72 equals the cosine. So this is the same thing as doing cosine of 90. I'm using degrees because that's what they gave me, minus 72 degrees. And so 90 minus 72 would give us 18. So sine of 72 degrees and cosine of 18 degrees, these two are cofunctions of each other. And you'll know because these two angles have to add up to 90. And then sine is the cofunction of cosine. Okay, and then let's say they gave it to us in radians and they use cosecant. Well, cosecant of pi over 3. Remember, cosecant and secant are cofunctions. Cosecant, secant. And you'll hear that root word. And since they gave it to you in radians, you're going to have to change pi or 90 degrees to pi over 2. Minus our given angle, which was pi over 3. Now, about the radians, with the radians, you're going to have to get a common denominator. So the common denominator of 2 and 3 is 6. So this would be 3 pi over 6. And then this would be 2 pi over 6. And so by subtracting those, you're going to get secant of 1 pi over 6. And then with these, pi over 3 and pi over 6 should both add up to pi over 2. That's one way you can check it. You already know that pi over 3 is 2 pi over 6 plus 1 pi over 6 gives us 3 pi over 6, which reduces to pi over 2. That's how you know you did it correctly. And then cosecant is the cofunction for secant. And if you needed to try another, you can always try your checkpoint just to make sure you're doing it right. So sine of 46 degrees. And then I'll give you one with the radians. Cotangent of pi over 12. So I'll give you a second where you can try that. Okay, so for the first checkpoint, sine of 46, we know that sine and cosine are cofunctions. And to find the actual degree that is complementary, you have to do 90 minus 46. And we're using degrees because that's what they started with. That'll give you 44 degrees. You have to make sure they add up to 90. And then the second example was cotangent of pi over 12. Well, since they start off in radians, you have to change 90 to pi over 2. And if you know that cotangent and tangent are cofunctions. Now, since we're subtracting with different denominators, you have to get the denominators the same. So pi over 2 is the same thing as 6 pi over 12 and minus 1 pi over 12. That's how we ended up with 5 pi over 12. So that's how you do your cofunctions. Okay, our last concept is evaluating trig functions with a calculator. And most calculators will have the keys marked sine, cosine, and tangent. So the best thing to do is look at your calculator and make sure that you can locate those 3 keys. Now, the key then is to be able to find the reciprocals because we don't have cosecant, secant, and cotangent on our calculators. So all we have are the sine key, cosine key, and then the tangent key. So their reciprocals are not located on the calculator. And then another thing that you want to do, well, before you even start, is to set your calculator to the correct mode. Depending upon how the acute angle is measured, you're either going to be in degrees or radians. So you have to make sure you look at how it's given to you. So if it's in degrees, you'll know because you'll see a degree. You want to make sure that you go to mode. So you're looking for this on your calculator. And depending upon the problem, they're either going to ask it for you in degrees or they're going to ask you for it in radians. Okay? Then after you do that, you have to figure out, are they asking you for the regular function, sine, cosine, and tangent, or are they asking for the reciprocal functions? And if they are asking for the reciprocal functions, there is a reciprocal key. Reciprocal. And it looks like this. Some of them on the scientific calculators will look like this, where you can actually see it doing the reciprocal. Or on the graphing calculators, it looks like this, x to the negative 1, which means reciprocal. So for example, if you had to find, or they ask you to use your calculator to do secant of pi over 12. Well, first of all, you see that this is radians, so you have to make sure you change your mode to radians. So I'm just going to put mode has to be in radians. Now, if it's a scientific calculator, you're going to actually see the word RAD on the bottom of the screen. But if it's a graphing calculator, you're going to have to actually go to second mode and make sure that radian is highlighted. And so what you're going to do, if it's a, I'm just going to put S for scientific calculator. After you change the mode, you're going to do pi divided by 12 equals Then you're going to hit the cosine key, and then the reciprocal key. And that should give you your answer. And then if it's the graphing calculator, you're going to hit cosine pi over 12 and do the parentheses. They automatically pop up. And matter of fact, if you want to put it all in together, I'm going to do a double parentheses. And then you'll hit the key, your reciprocal key, x to the negative 1, and then hit enter. In either case, and most of these are going to tell you to round to 4 decimals. You should get 1.0353. So make sure you try that. Get your calculator, type that in to make sure that you get that answer. Now, if you have a smartphone, you can always download a graphing calculator. There are free apps for that. And if you're not sure about which app, you can ask me about it tomorrow. Okay, I'm going to try some other ones just to make sure you practice getting the right answer. Okay, here are 4 more to try. If you notice, examples A and C are in degrees, so make sure that those are degree modes. And then examples B and D, those are radians. So I'm going to put D, R, D, R. So you know degree radians. And then I'll give you a chance to actually type those in. And then I'll give you the answers. And remember, we're rounding to 4 decimals. Okay, and these are the answers to those 4 if you did it right. One thing I also want to let you know, if you use the TI-30X, those are the blue calculators like the ones I have in class. Those also work like a graphing calculator. So you'll use the same procedure. So even for the, I'll put TI-30X. The blue calculators work the same way. So for example, if you had to do cotangent, you would do double parentheses tangent. I'm doing example B. 1.2. Oh, make sure you're in radians mode. So you would actually press the DRG and then cursor over to make sure you're in RAD mode. You could just hit enter and it'll put it. And then once you type that in, your reciprocal key also looks like the graphing calculator. And then you hit enter. And you should get 0.3888. Okay, so that's just something to know about the TI-30. And that's the end of this lesson.